Okay, so I'm going to explain how the ossicles work. So this is a simplified version of how the ossicles connect together. You have the eardrum, and then the first ossicle connecting up to make this shape here, that then connects up to the cochlea in that direction. And what happens here are two things. First, the force is magnified, and I'll explain why in a second. Magnified. And then secondly, the pressure is magnified as well. Because the whole point of this area here is to increase the pressure from this area here, the eardrum, to the cochlea. You must magnify it because the cochlea needs almost like a huge amplified version of the pressure that's being received by the eardrum, because the cochlea is where all the really sensitive interpretation of the sounds is going to take place. This is where the signal becomes converted into an electrical signal that the brain understands. So let's actually look at how this happens. Okay, so the first step is, how is the force actually magnified? Now this is through something called a turning moment. If we have a tiny pivot here, okay, then what this looks like, if I draw it to one side, is the arrangement of the bones is like this, and a pivot is here. If you can imagine the pressure pushing here backwards and forwards, what it does is it swings the whole arrangement, let's try it in a different colour, in and out about that pivot. Okay, so it slides this way and then it slides back the other way like that. So it's rotating. Okay, and as it rotates, this section, the force, makes this force happen. Okay, now there is an effect called a force magnification, and I'm going to write it out here, but don't worry if it's too much to handle because it's not actually on the syllabus. What we have is a turning moment. The turning effect, or the turning moment of any object that's turning, is a product of the force times the distance. So if we compare both of these forces, F1 and distance 1, okay, that's the total. F1 times distance 1 is the total turning effect that's given by this part of the ossicle, and that's due to the pressure from the eardrum. Okay, so that's making it move backwards and forwards, and it's causing this turning moment. Now, because it's connected, then this section here, F2 and distance 2, okay, has the same moment. It's a conservation thing. So F1 times D1 would equal F2 times D2. Okay. Now I'm going to express that clearly. F1 D1 equals F2 D2. Okay, so this is moments. Now let's see what happens if we consider the distances. Okay, now we'll assume, just to make things simple, that D2 equals half of D1. Now, what has to maintain itself is that this side equals that side. So if you think about matching this up, if we make D2 half, okay, and change that to D1, in order to compensate for that, we must add a 2 here. Okay, so decreasing that distance in the lever by a half magnifies the force. It doubles it. In reality, what happens is it's magnified by 1.5. So it's a ratio of thirds. But you don't need to know the actual ratio. Again, it's very unlikely that this will come up, but at least you have some kind of concept of how force can be magnified by something called a lever system. The next section is easier to understand, so stick with it. So now we know a little bit about how the force is magnified. Let's have a look at pressure magnification. And this is a lot more straightforward because it involves this idea of pressure equals force over area. Now let's have a look at the arrangement more clearly. This direction is the pressure build-up from the eardrum, okay? And we have pressure PS, and we have an area of eardrum AT. So that causes a force to be applied on the ossicles. Okay, so let's have a look at that force. Force equals pressure times area. Okay, in this case it will be AT, and pressure would be PS. That force is then magnified, which we talked about already, but you don't need to worry about that now. Let's just see what happens when we get to this area here. The force is conveyed, okay, so this force is the same here. And now let's have a look at the pressure, or PI, that's caused in the cochlea. So rearrange this formula. Okay, we're going to write, how do we calculate pressure? Well, we calculate pressure equals force over area. Now the force is equal to PS, AT, okay, divided, which is, I'll remind you, the pressure that's acting here times the area of this tympanic membrane, okay, but this time divided by the oval window area here, A0. So in fact, if you think about this, the pressure I here going into the cochlea is going to be equal to the pressure in the eardrum, or coming from the eardrum, times the ratio of these areas. Okay, now if you notice, the area of the oval window is much smaller than the area of the tympanic membrane. So if I rub all this off, I've just realized what a mess it is. Okay, rub this off, we have here a massive difference in areas. So if we measure that, if we try and make that ratio of this area to this area as big as possible, what we're going to do is we're going to magnify the pressure. Okay, so that's how this works. Firstly, we have a force magnification, and then we have a pressure magnification. And the pressure magnification is because of the difference in the areas. If on top of this you add what I previously told you, let's see if I can change colors completely. Okay, you'll get an even greater result here in your formula, because if the force magnifier has made 1.5, the force greater by a factor of 1.5, then your new pressure here at the oval window is going to be the ratio of the areas times the pressure that you had incoming from the eardrum times that factor 1.5. Okay, so to sum up again, how do the ossicles work to transmit and magnify pressure? Well, firstly, with a lever system, which magnifies force. I think that will be enough to convey that you show understanding. And then secondly, you have a difference in area between the tympanic membrane, oval window, which magnifies, which magnifies pressure. And there you go.